Also, okay. So, all right. So first, let's figure out when it's possible to multiply matrices, right? To multiply matrix A by matrix B, it still has to do with the dimensions, but a little differently than when we add them. In this case, the number of columns of A must be equal to the number of rows of B, okay? And then the product AB will have a specific set of dimensions. All right, so how do we do this? This is how we do it. Suppose you want to multiply A times B. You write down the dimensions for A, you write down the dimensions for B. So suppose A is 3 by 2 and B is 2 by 4. These inner numbers have to be equal to each other. If the inner numbers are equal to each other, then you can multiply them, okay? And then once you've realized, or once you've established that yes, you can multiply the matrices, the resulting matrix will have dimensions 3 by 4. These will be the dimensions of AB, okay? So, take a look here. Let's practice with that. Determine whether it's possible to multiply the following pairs and state the dimensions of the product. Okay, so let's see. What do we have here? We have a 3 by 2 and a 2 by 4. Is it possible to multiply these? Yes, it is, because these two numbers are the same. And the resulting matrix will be a 3 by 4. So let's see what a 3 by 4 looks like. A 3 by 4 will have 3 rows, 4 columns, right? So look at the product. When you multiply those two matrices, this is what you get, right? So do you see how it looks nothing like the matrices from which it came? So that's a possibility when you're multiplying matrices. It's very different from adding or subtracting. Okay, what about this one? We've got a 2 by 3 and a 2 by 2. Do we multiply them? Can we multiply them? No, all those 2's, right? You just don't have one in the right place, right? So this is not possible. Right? And this one we said was going to give us a 3 by 4. Okay, the one thing I cannot stress enough is matrix multiplication is not cumulative, which means in numbers, right? With numbers, you can do 3 times 5, or you can do 5 times 3, and they both equal 15. Not so with matrices. A times B is not the same as B times A, right? So if you switch the order, you get a completely different matrix. How trippy is that? Like, could you imagine 3 times 5 gives you 15, but like 5 times 3 gives you -8 or something, right? That's sort of how matrices work. It's weird, okay? Okay, let's multiply some matrices, guys. So I've made this page to make it like sort of interactive, or to help us navigate through the multiplication. We're gonna go through one very, very meticulously, slowly, for one set of matrices, and then we'll do some more. They're not always going to take you a full page to do, right? But I've just expanded this one so we can lay out everything. Okay, we're going to multiply A times B. Let's first figure out the dimensions. Here, A is 2 by 3, and B is 3 by 2. So does anybody want to tell me what the dimensions of the product are going to be? Just yell it out.
2x2.
It's a 2 by 2, yes. All right, so we're going to have a 2 by 2 matrix like this when we're done multiplying. Okay, so what you do is this. You first draw a skeleton of a 2 by 2 matrix like I've done here, right? That's this one here. You see how I've got a 2 by 2 matrix, right? 1, 2, 1, 2, okay? And then what you want to do is this. We're going to start filling in these spots. I'm going to start by filling in this one first, okay? Now, what position is that in my resulting matrix? That's row 1, column 1, right? So that's what we're doing first. We're going to start with the first element, row 1, column 1. In order to generate that value for row 1, column 1, you know what I do? I go to my matrices and I take row 1 and column 1 in that order to multiply them with each other. Okay? Now, here's how we're going to multiply them. Watch my screen for a minute. Here's what we do. How many entries or elements are in row 1? 3. How many are in column 1? 3. You see that? They gotta match up. Now, you have to pair them up. Here's what you do. First number with the first number is 2 times negative 3 plus, okay, now watch my screen. Second number with the second number is negative 3 times 5 plus, go back to your matrix. Third number with the third number, 1 times 6, right? You see my system here? Okay? So the way I do it, if you look at me for a minute, the way I usually do it, so you've got a row and a column, so it's like first, second, third, right? First, second, third, first, second, third, and so on, and you move down the list, okay? So that's row 1, column 1. Next, okay, we're gonna move on to the next. Now it's gonna be row 1, column 2. Here, this one. Row 1, column 2. So here, I take row 1, column 2 in that order. Don't switch up the order because you won't even have the same number of elements in there. And then we do the same thing. First number with the first number, 2 times negative 4 plus, go back to the matrix, negative 3 times 1 plus 1 times negative 2. Okay? Next, let's move on. Move on to the next. This one now. Okay? Where is this? It's in row 2, column 1. So I take now row 2, column 1. Right? First number with the first number. 5 times negative 3 plus. Second number, whoops, I had a square there. 0 times 5, oh, I love those zeros. Plus, last one's negative 2 times 6. These are, yeah, Cooper.
Just a quick question. So let's say I wrote in this problem like 5 times 0. Would that matter?
No.
Okay.
5 times 0 wouldn't matter. That's pretty much the only thing that doesn't matter.
Okay. Because you said it's not commutative, so I was just like,
yeah.
I wasn't sure if it was for the entire thing or just
right.
for the.
Yeah, it's for the entire thing. The inside stuff are still numbers, so they're commutative, but the entire thing is not.
All right.
Okay. Lastly, move on to the next element. Here, this is now row 2, column 2. So I'm going to take row 2 with column 2. And same situation. First one times the first one, 5 times negative 4, plus 0 times 1, plus negative 2 times negative 2. Okay. When you've filled them all up, okay, now you just have to go and you have to do the multiplying. So let's go ahead and do that. Here I had 2 times negative 3, so that's negative 6, minus 15, plus 6. Okay, so look, I've got 4 elements here. You know what, let's, okay, so what does that give me? Negative 6 and 6 go away, so I've got negative 15. Next one, negative 8, minus 3, minus 2, negative 13. Bottom ones, negative 15 plus 0, minus 12, negative 27. Lastly, negative 20, 0, and positive 4, negative 16. All right? And there we go. You can give yourselves a hand. You can pat yourselves on the back. You have now multiplied your very first set of matrices. This is a mathematical rite of passage. You are now mathematical adults. Congratulations. As you can see, this is something where it's not a good idea to multitask, right? So you can't multiply matrices and watch your favorite show at the same time, or multiply matrices and be texting your friends at the same time. Like, this is when you got to tell everybody, you know what? I got some matrices to multiply. I'll get back to you in 10 minutes, okay? Because then, it's just numbers everywhere, okay? All right. And if your friends love you, they will give you up for 10 minutes for a few matrices. They will. Okay? Otherwise, they're not worth keeping, honestly, right? Okay. All right, let's move on. Let's do another one. We're going to multiply g times h, right? So let's see here. For g, I have 2 by 3. H is a 3 by 2. I can multiply these, right? Yes, I can. And I'm going to get a 2 by 2 in the end. So always write them down, because it gets confusing and you want to be able to mark your matrices. Okay. So the result is going to be a 2 by 2. 1, 2, 3, 4. Okay? All right. So same situation. Let's start with the first one. Row 1, column 1. Row 1, column 1. Okay? 1 times 2 plus 3 times negative 2. And look, you don't have to write them all out like that. So like here, when I have 3 times negative 2, I can just say negative 6 plus negative 5 times 1, negative 5. Next, this one is row 1, column 2. So I got to do row 1, column 2. All right. Can somebody tell me what numbers I'm going to get here? So the first one is a 3 plus what? Can somebody tell me what the next ones are going to be?
3 times negative 8.
Right, which is negative 24 plus?
Negative 35.
Negative 35. Awesome. Next, let me erase these. Reset our matrix. This one is row 2, column 1. So row 2, column 1. Okay? All right. So I'm going to call on you guys, and that's cool, right? So it's okay if you're not sure. Just I'll skip you. All right. What's the first one? Rachel, any ideas what the first term here is going to be?
Is it the first row times the second column?
It's the second row times the first column here, right? So second row, first column.
Okay. So 4 times 2.
Absolutely, 8. And then plus
2
Sam?
times negative 2.
-2 times -2, so that's 4. Sam, any ideas for the last one?
Wouldn't it just be 0 because it's
Absolutely.
1?
Absolutely. Lastly, I have this last one, row 2, column 2. So I get 4 times 3, 12, plus -2 times -8, 16, plus 0. So finally, adding them all up, I get -9. And then what are we going to get here? 3 minus 59, so -56, 12, 28. Okay. All right. Well, what about HG now? For HG now, we're going to switch the order, right? Well, let's see. Can you even multiply them? H is a 3 by 2. G is a 2 by 3. Oh, yeah, okay, you can multiply them. So let's see. Let's write them down here. This is H. Times G, 1, 3, -5, 4, -2, 0. What's the result going to be here? What do you guys think? We're going to get a 3 by 3. Okay. All right, so look. Here, it's row 1, column 1. So look, how many are in row 1 that I've circled? 2. How many are in column 1? 2. You see how they always match up? That is not a coincidence because you've got to have an equal number of pairs later. Here, the first ones, it's going to be 2 times 1, 2, plus 3 times 4, 12. Okay? All right, what I'm going to do is I'm going to give you a few minutes to go ahead and fill out the rest of this, okay? And then we'll get back. I'll pause the recording for a minute. So one thing, okay, so here's the resultant matrix, right, for H times G. All right, so do you see the difference? When we did GH, we got this matrix. HG, something different entirely, right? So right there, look at how different these are from regular numbers. Like 3 times 5 is 15, 5 times negative, 5 times 3 could be -8. Like that's crazy. But look, it happens with matrices. Okay? All right. Let's do the last bit and then we can move on. So here I have D times E. And let's see, the dimensions of D are 2 by 3. E is also 2 by 3. Not possible, right? So you just write not possible. All right? Okay. Let's do some applications. You own 3 car rental locations. And you offer 3 choices for vehicles at each location. A sedan costs $80 a day. A minivan costs $100 and an SUV $125 a day. The chart below shows the number of each type of vehicle available at each location, right? So in your, in A, right, in your Calabasas location, you've got 7 sedans, 5 minivans, 2 SUVs, right? And then, in your like Agora location, you've got 6 sedans and so on and so forth. So the first question here asks, write a matrix V for the number of each type of vehicle at each location. Then write a cost matrix C. So V is the vehicle matrix. And again, to write the matrix, we take away the chart aspect of it and just focus on the values. So we've got 7, 5, 2, 6, 8, 6, 4, 3, 0. That's the vehicle matrix. And then the cost matrix C, right, is this. It's how much each one costs. But now, you kind of do have to, not kind of, you have to mind the order here. You see how here this was a sedan and a minivan and an SUV? Here, when you write the cost matrix, how much each costs per day, go in the same order. So a sedan is $80, a minivan $100, and an SUV $125, right? Sedan, minivan, SUV. So you see how the arrangement of the columns here is the same as the arrangement of the rows here, right? That's not by coincidence, that's by design. Okay. Now, write a matrix for the total daily income, assuming that all cars are rented. Okay, so if you rent all the cars in all the locations, how much money are you going to make in each of your locations? So to do that, the total income, right, you have to multiply V times C. So 7, 5, 2, 6, 8, 6, 4, 3, 0 times C, 80, 100, 125. Okay, so what have we got here? A 3 by 3 and a 3 by 1. So my resulting matrix is going to be a 3 by 1, 3 rows, 1 column. So here's how this works. Here, that's row 1, column 1, right? So look, I've got sedan, minivan, SUV, sedan, minivan, SUV. I multiply them all out. So I have 7 times 80 plus 5 times 100 plus 2 times 125. Next one is row 2, column 1. 6 times 80, 8 times 100, 6 times 125. Lastly, row 3 times column 1. So 4 times 80 plus 3 times 100 plus 0. Okay? All right, so let's multiply these out. What do we get here? Okay. So what does this represent? This represents how much money I get in each of the locations A, B, and C daily if I sell all of them, right? So do you see how well organized it was to use matrices to do this, right? Rather than just, like multiplying random numbers and having all these like spreadsheets everywhere, right? So finally, what is your daily income from all 3 locations? The daily income from all 3 locations is the sum of all 3 of these. So 1310 plus 2030 plus 620 And that's $3,960. Okay? All right. So that is that.